Hello, so today we are going to do this problem called trim binary search tree. So the problem says that we get a binary search tree and we get the root of a binary search tree and the lowest and highest boundaries as low and high. And we want to trim the tree so that all of its elements are in low and high boundaries. And so basically we want to remove all elements that are smaller than low and all of those that are higher than the value high. So this is essentially what we need to do. And we need to maintain the structure, which basically means that the remaining elements should have the same structure. So if a value was a child, if a node was a child of another node, it should remain a child of it. They say here that it's guaranteed that there is only one unique answer. And so the goal here is to return the trimmed binary search tree. And we'll just return the root node. Yeah, pretty much. So let's take a look at some examples. So here, okay, so let's take a look at this first example that we have here. So for example, here we get low is equal to 1 and high equal to 2. And so if we take a look here, 0 is smaller than 1, so we need to remove it, and so we return just 1 and 2. That's what we have here. And then if this one is easier because we have 0, because 0 it doesn't have any children. But let's take a look at the second example where we have a node that is outside of the bounds but has children. So for example, 0 and 4. So 0 is smaller than low, and 4 here is bigger than high, right? So for 0 we want to remove this, but we want to keep 2 and 1, the right children, because they are within the bounds. And so what we need to do is just put 2 as the left child of 3, which is what we did here. But we need also to 1 is, we need to keep 1, so we kept 1. We keep the entire subtree essentially. And here 4, it's easy to remove it because it doesn't have any children. Yeah, so this is basically the main idea. So let's see how we can solve it. Okay, so how can we solve this problem? So first, just a reminder of what a binary search tree is. So a binary search tree is just a tree where each node, its left children are smaller than it, and its right children are bigger than it. That's pretty much what a binary search tree is. Now, in terms of solving this problem, we can think of it in multiple cases. And so if we have only 3 cases. Either the value for each node we have only 3 cases. Either the value is smaller than high, smaller or equal to high, or smaller or equal to low, so it's within bounds, or the value is smaller than low, or it's bigger than high. So these are the only cases we have. And so if we cover each of these 3 cases and handle it, we should be good, right? So let's see how we can do it. So first, the case where, the first case where, let's call it case 1, where we have node value, or let's call it A for our case. A, so this is just the node value, is smaller than, is in bounds, right? So in that case, we have something like this. So we have A, and then we have a left side, and then we have a right side. What should we return in that case? Well, just for A, we should return A, so I'll mark with green what we should keep. So in that case, we should have A. For the left side, we should keep it, but we should transform the left side as well. So let's say we have maybe our low is equal to 1 and our high maybe is equal to 2. Then if we have maybe, okay, let's just have more values here. Let's have, I don't know, 3. So if we have 2 and then have 1 here, and then have 0 here, and maybe 3 here, we should, the final result should be only 2, 1, 3. We should remove this 0 here, right? We should remove the 0, which means basically we need to apply the function recursively to the left side, right? And so that what I'm going to mark that as TL, which means trimmed left, right? For the other side, we keep it as well, and we need to have, sorry, this is TL, right? Trimmed left side. Here we do the same thing. Let's say just in case we had 4 here, we need to remove 4 as well. And so we need to apply the function also to this side. Okay. And so for this first case, what does this mean? We keep the node, right? But we need to change node.left. Needs to be, we apply the same function, trim on node.left. Okay, let me just give us more space and write this here. So we need the node.left to be equal to the trimmed left side. So that's node.left. And we need the same thing for node.right. So this is what I marked it as TL. And this needs to be node.right. Okay. And then we can just return the node, right? Because that's, we want to return this entire thing here, right? Okay, so that's how we handle the first case. Now how should we handle the second case where the node value is smaller than low? So for that case, let's mark it here. So our second case is when the value is smaller than low, or A is smaller than low, right? So what should happen in that case? So in that case, well, let's mark it here. So we have A, we have left side, and then we have right side. So if A is smaller than low, right, so that means that the left side is also smaller than low. All of the nodes are smaller than it, okay? Which means basically we need to remove this entire side, okay? Which means we need to just keep the right side, but trim the right side as well, just in case. Let's take an example. If we have low equal to 1, and again high equal to 3, or maybe, yeah, let's have a higher value here. Let's say low is 3 and high is 5, right? So if we have, let's say this is 2, and maybe 1 here, 0 here, and then here we have 3, and maybe we have 5, okay? So we remove this side, right? We remove all of this, okay? But we need to apply trim as well to this side so that we can remove 5 as well, right? And so the final result we need to have here is just TR, right? So the trimmed right side. Okay, so what this would mean is that our function here needs to be so what does this mean for our for the code here? That means basically that we want to just return, we don't want the node, we just want to return the trimmed right. So we just return trim called on node.right. Okay, now our third case is when it's higher than high, right? So let's write that down. So case 3 is when node.val is bigger than high. Okay, so in that case basically A is bigger than high. Okay, so we have this, we have A, and then we have the left side, and then we have our right side here. Okay, so A is bigger than high. That, and high, we know the right side is all of the values on the right side are bigger than A. That's the property of binary search tree that we said here, which means that all of the right side is bigger than high. Okay, which basically means we need to delete all of this. So we need to remove all of this. We need to trim all of this side, which means what we have remaining is just, again, we apply trim to the left side. Okay, just in case there are values here that are smaller than low. And so you get the idea. In this case, what we need to return is just calling trim again on the left side. Okay, node.left. And that's pretty much it. So we need to, basically what we need to do is, for the base case, when node is null, we need to return none, right? We need to return null in that case, and then we can handle each case. So we can check this. If it's in this case, then we need to return this. If it's smaller than low, we need to return this. If it's bigger than high, we need to return this. And that's pretty much it. Yeah, so let's write this down and make sure it passes test cases. Okay, so now let's apply what we just saw in the overview. So we need our recursive function, just to simplify, to not have to pass all of these parameters. And then we need our base case, of course. So in that case, we just return it's null, so we return null, which is none in Python. And now we need to apply our cases. So if node.val is in the bounds, then we need to return, we need to first do exactly what we said. So apply, trim the left side in case there are elements smaller than low. Do the same thing for right. We want to keep node because the value is within the bounds, and so here we return node. Otherwise, if node.val is smaller than low, then we want to return only the trimmed right side, because we know that the left side is also smaller than low in this case, and so we can just do helper node.left .right. Otherwise, which you can also do else if you want, but here, just to make it clear, we can return node.left because the right side is also bigger than high, so we shouldn't handle it. And just to, usually with these recursive functions on trees, we handle the left side first. So I'm just going to put that case first. And we need to call the function, right? So that will need to be return a helper on the root, right? And that's pretty much it, actually. One small modification we can do here, just to make this, we can handle these cases when it's outside of bounds first. And then we know that if those two are not the case and we didn't return, then we have within the bounds case, and so we can do that after it. And that's pretty much it. So let's run this and submit it. Yeah, and that's pretty much it. It passes test cases. Yeah, thanks for watching and see you on the next one. Bye.